All right, example 2 says graph the system of linear equations. Now notice that we have two equations here and not inequalities. The first equation is negative 4x plus y equals 4, and the second equation is x minus 2y equals 6. Now I'm going to put both of these in slope-intercept form so they are easier to graph. So this one, if I were to add 4x to both sides, that would give me y equals 4x plus 4. And then the second equation, I can subtract x from both sides. So I get negative 2y is equal to negative x plus 6. And then I want to divide both sides by negative 2. Now, if this were an inequality, we would have to worry about flipping the inequality symbol, but it's an equation, so we don't have to worry about that. So then we have y equals 1/2 x minus 3. So I've gone ahead and I've changed both of the equations that we were given into slope-intercept form. So I'm just going to highlight those. I boxed them earlier, but I realized I usually box my final answers, and those are not our final answers. So I'm going to go ahead and start to graph. So the first equation, maybe I'll graph in green, and our y-intercept is the point 0, 4. Oh, let's label our axes, our x and y axis. So our our y-intercept is the point 0, 4, which is right here. And the slope there is 4, or 4 over 1. So I'm going to go up 4 units and right 1, and then just maybe add in another point there. And I will go ahead and connect those to form my line. And then maybe the second equation I'll graph in blue. So the y-intercept of our second equation is the point 0, negative 3, which is right here. And the slope is 1/2, so we're going to go up 1 over 2. We could also go in the other direction. We could go down 1, left 2, and I'm going to go ahead and connect those now. Okay, so this is a system of equations, and the way that we've graphed these two lines, there's only one solution because there's only one point where these two lines are intersecting, and that is happening right here where I'm highlighting it in yellow. And if you're having a difficult time seeing, it looks like that's the point -2, -4. So although it doesn't ask for the solution of this system of equations, we can give it anyway. The solution is -2, -4. What that means is if we were to plug that point into both of our equations, it should give us true statements. Let's go ahead and just check that really quickly. So I'm going to plug it into our first equation, -4 times -2 plus -4. And hopefully, if we have this correct, it will equal 4. So let's see. -4 times -2 is +8, and then plus -4 is equal to 4, which is what we wanted right here. So that checks off. And let's go ahead and plug our ordered pair into our second equation and see if that works as well. So we have -2 minus 2y, which y we're going to replace with -4. And if we simplify that, hopefully it should equal 6. So we have -2 minus 2 times -4 is -8. And then that simplifies to -2 plus 8, which is equal to 6. And that is the value that we wanted there. So it turns out that that is the correct answer. Now, let's move on to example 3. Notice that example 3 is almost exactly the same. However, now we have a system of linear inequalities rather than a system of equations. And so I'm just going to really quickly throw on the graph. It's going to look very similar to our last example. Okay, so I've gone ahead and I've graphed our two inequalities on our xy plane. The only thing that looks different from our previous example and the graph that we drew is that the second inequality says x minus 2y is greater than 6. Because it says just greater than, I made the blue line a dashed line. The first inequality says negative 4x plus y is less than or equal to 4. That means that my green line should be a solid line. So I gave an example of both to kind of show you the difference versus, or when we have a solid line versus when we have a dashed line. Now, because this is a system of linear inequalities, we're going to have infinitely many solutions that satisfy both of these inequalities. In our system of equations, there was only one solution, and that was the ordered pair -2, -4. However, because these are inequalities, there are going to be infinitely many solutions. Now, if you look at the xy plane that we have kind of graphed here, there's 4 regions that we've split up our graph in. There is this region here, so we could think of that as the first region. There is this second region here. There is this third smaller region kind of in the lower left corner. And then the last is kind of the one in the lower right corner. So those are our 4 regions, and all of our solutions to both of these inequalities is going to fall in one of those regions, and it's our job to figure out which of those regions makes it true. So there's, several different ways that we can do this. I like to draw arrows to kind of think about which side we're on. So let's start with our green line and let's plug in the point 0, 0. So -4 times 0 plus 0. And if we simplify that, that is equal to 0. Is that less than or equal to the value that we have here? 4? It is. This is a true statement. Now, what that means is if we're looking at the green line, the solid line, we're going to shade in this direction because our origin, this point right here, falls kind of to the right-hand side of our line. So that means that if we were to shade it, we would shade in this direction there. Now we want to think about our blue line. Would we shade above the blue line or below the blue line? Let's use the origin again as a test point. So I'm plugging in my origin into my second inequality. So 0 minus 2 times 0, if we were to simplify that, that would give us 0. Is that greater than 6? No, 0 is not greater than 6. That is false. So that means that we would not shade above the blue line because that's where the origin lies. So we're going to shade in the opposite direction since there's only 2 places we can shade. There is above the blue line and below the blue line. Now, if I were to have shaded the green and blue, maybe I can go ahead and do that. So green is anything on like the right side of the green line, and then the blue shading is going to be everything down here. Now, I don't like to double shade like that because it gets very messy. So I'm going to go ahead and undo those 2 shadings, but hopefully you saw that and saw where the 2 colors overlapped. Now I'm going to use my highlighter to highlight the region So that's going to be everything here. So what I'm highlighting in yellow, that everything there is our solution region. And mathematicians actually have a special name for this, and we'll talk about it more in a later section. However, let me just write it down for you. This highlighted yellow area is called the feasible region.